Welcome to the Pressurization System lesson. In this lesson, you will gain a basic understanding of how the pressurization system operates. Cabin pressurization is controlled by regulating the discharge of conditioned cabin air through the forward and aft outflow valves. Normally, the outflow of cabin air is split equally between the two outflow valves. However, cabin altitude and full ventilation rates can be maintained by either valve. In addition to outflow valves, positive and negative relief valves are installed in the aircraft to protect the fuselage against excessive pressure differential. Controls for the pressurization system are located on the overhead panel. Review the pressurization panel controls before pressing the Continue button to resume the lesson. Aircraft pressurization can be monitored on the primary ICAS display. Review the indications before pressing the Continue button to resume the lesson. In flight, the cabin pressure control system operates in climb mode, cruise mode, or descent mode. The pressurization system uses ambient pressure and flight plan data from the FMC to calculate a cabin pressurization schedule. The schedule provides a comfortable cabin climb to cruise altitude. Prior to rotation, the system supplies a small positive pressurization to provide a smooth cabin altitude transition. In climb mode, cabin altitude increases on a schedule related to the airplane climb rate and flight plan cruise altitude. If the takeoff field elevation is higher than 8,000 feet, the cabin altitude descends to the target altitude while the airplane is climbing. Any planned level segments in the FMC climb path are included in the total time required for the airplane to reach the top of climb. During the planned level segment, the cabin altitude will continue to increase. For unplanned level segments or when VNAV is disengaged, cabin altitude will remain constant as long as airplane altitude is not changing. When the airplane climb flight path is above the FMC climb path and maximum cabin pressure differential is reached, cabin rate becomes a function of airplane climb rate, so maximum cabin differential pressure is not exceeded. In cruise mode, the cabin altitude normally remains below 6,000 feet. During some degraded operations, the cabin altitude may climb up to 8,000 feet. If cruise altitude is unavailable from the FMC in auto, the default cruise altitude becomes 43,000 feet. The pressurization system enters descent mode once airplane descent has been initiated. During descent, the cabin altitude decreases to slightly below the FMC planned landing altitude to ensure the airplane lands pressurized. At touchdown, both outflow valves open to depressurize the cabin. If the destination airport elevation is greater than 8,000 feet, the cabin altitude climbs to 6,000 feet after takeoff and remains there during cruise. The cabin altitude will then climb to the destination airport elevation during descent. Placing the outflow valve switches to manual will switch the pressurization system into manual mode. When the outflow valve switches are in manual, manual appears in the outflow valve switch. The outflow valve indication changes to amber, and M appears on the outflow valve indication. When the system is in the manual mode, holding an outflow valve manual switch to open or close will open or close the related outflow valve. The current outflow valve position can be monitored on the ICAS display. If the outflow valve position is not available on ICAS, holding an outflow valve switch in the desired position for 30 seconds moves the valve from full open or closed to the selected position. Landing altitude is normally provided by the FMC. When necessary, the landing altitude can also be manually set using the landing altitude selector. Pulling the selector out removes the FMC landing altitude and changes the landing altitude indication on the ICAS display to amber. The selector can be rotated clockwise to increase or counterclockwise to decrease the landing altitude setting. Two positive pressure relief valves are installed on the aircraft to prevent differential pressure from exceeding structural limits. During an excessive positive pressure situation, the cabin differential pressure indication changes color from white to amber, then red. The valve doors open to relieve excess pressure. When the differential pressure returns to an acceptable value, the cabin differential pressure indication changes color from red to amber, then white. The relief valves reset and close. After the relief valves close, the blowout doors remain open and must be manually closed by maintenance. Four negative pressure relief valves protect the airplane structure against an excessive negative pressure differential. When there is a negative pressure situation, the negative pressure relief valves open inboard to equalize pressure. If landing altitude is unavailable from the FMC and not set in manual, the advisory message "Landing altitude" is displayed on ICAS. If this occurs, the cabin altitude controller assumes a landing altitude of 2,000 feet. If depressurization occurs, the outflow valves close to preserve cabin pressure. The outflow valves remain closed while the airplane is descending and cabin altitude is increasing. When the airplane reaches 15,000 feet or descends below the cabin altitude, the outflow valves fully open for the remainder of the flight. During the descent, do not attempt to manually close the outflow valves.